we are going to continue chemical kinetics. First, we should know what is rate of reaction. Consider a reaction of reactant A reacts and it forms a product P. So, with this reaction, the rate of reaction is defined as decrease in concentration of reactant A in an infinitesimally infinitesimally small interval of time of time. So this can be mathematically represented as minus dCA to dt, which means the concentration of reactant A decreases as time goes, means the reactant A is converting into product P. Therefore, the mathematical expression is given dCA by dt. So decrease, it is indicated with the negative sign. So decrease in concentration of reactant with time is nothing but rate of the reaction. Generally the time interval is very small. So R is equal to minus dCA by dt. This is the rate of reaction with respect to reactant. This can also be expressed in terms of product. So change in concentration of product with respect to time. Here we have positive sign. This negative and positive sign indicates how the change occurs. So here positive means the concentration is increased with respect to time. As time goes on, the concentration of product is keep on increasing. This can also be graphically represented. If you plot time versus time in the x-axis and concentration in the y-axis. So for reactant, initially the concentration is higher. So when time goes on, it keeps on decreasing. Means the product starts and it forming. So when the product starts forming, the reactant concentration is decreasing. So here the product can be shown when the time goes on, the product concentration keeps on increasing. After the completion of reaction, it attains saturation. So this is graphically represented for the rate of the reaction if we consider a reaction A gives product. So decrease in concentration of reactant with respect to time or increase in concentration of product with respect to time is nothing but your rate of the reaction. So the rate of the reaction unit can be determined. So concentration divided by time. For concentration it is mole per liter and the time is already there. Either you can write time inverse or the second inverse. So this is the unit for rate of the reaction. So next we see rate law and rate constant. Rate law and rate constant. Before that, we will see one more reaction. Let us consider A plus Q gives a product. So how we can write rate for this? In terms of reactant, minus dCA by dt or equal to minus dCV by dt. So product is dCl by dt or dCm by dt. So this also we can call it as rate of the reaction. So if you know how to write the rate of the reaction, it is easy to understand the rate law and rate constant. So rate law and rate constant. So rate law and rate constant, and also I will tell about the order of the reaction. Then we will stop. In next video we will continue integration of rate expression for different types of reaction. To understand rate law, let us consider a reaction A gives product. A gives product. So rate depends on the concentration of reactant A. So rate, if the concentration of A is higher, the rate will also be higher. So we are directly writing R proportional to concentration of A. If you remove the proportionality constant includes here rate of the reaction we are dealing. So K is the proportionality constant, means rate constant. So rate directly depends upon the concentration of reactant A. So if you remove the proportionality, we have to include a proportionality constant, that is nothing but K. So R equal to K into Ca. This is how we are writing the rate law of the reaction. Suppose take a reaction with coefficient A moles of A reacts with B moles of B plus C moles of C gives product. How to write rate law for this? So here if you see, rate depends upon concentration of A, concentration of B, concentration of C. If you look carefully, here we have A as a coefficient, means how much moles is reacted in the reaction, and B moles, and here it is C moles. This coefficient or this comes in the power of A. So C to the power A, B to the power A, C to the power C. So if you remove the proportionality constant is included. So it is nothing but K Ca to the power A, Cb to the power B, and C to the power C. So this is rate law, and this is the rate law for this particular reaction, right? And here K is nothing but rate constant. So from the earlier reaction, it is easy to understand the order of the reaction. So your order of the reaction tells about, means order of the reaction can be defined as sum of the powers of concentration of reactant. If you look into it here, A is there in the power of concentration A, and here B, and here C. So if you sum all the powers, that is equal to order of the reaction. So it is nothing but sum of the power of the concentration of reactants gives the order of reaction. So we can, there is a different order of the reaction. For example, R is equal to K1CA1. This means it is unimolecular reaction. So the power is 1. So it is first order reaction. First order reaction. And R is equal to K2CA to the power 2. Here the power stands for 2 and it is second order reaction. Second order reaction. So two molecules are same. Therefore it comes to the power 2. If it is different reactant molecule, then Ca to the power 1, Cb to the power 1. So A is one reactant, B is one reactant. So both the reactant involved in the reaction. If it is unimolecular, both the reactions are 1 plus 1 is 2. And this is also second order reaction where the reactants are not same, different reactant. Second order reaction. So KCA to the power. This is third order reaction. This third order reaction depends upon the constant different reactant. If A 2 moles of A, 1 mole of B reacts, then this is also third order reaction. If 1A, 1B and 1C reacts, and this is also third order reaction. So we can write it accordingly differently, right? So here uh, the sum of concentration of reactant gives order of the reaction. So once again I am remembering what is the rate of the reaction. The rate of reaction is defined as decrease in the concentration of reactant with small interval of time. So that can be mathematically given minus dCA by dt. Here minus sign indicates the decrease in concentration of reactant. In terms of product, dCP by dt. Here positive sign indicates increase in the concentration of product. We have seen the graphical representation of reactant, order of rate of the reaction, plotting time in the x-axis and concentration in the y-axis. So rate law, considering the reaction, rate directly depends upon the concentration of reactant. If you remove the proportionality, then proportionality constant is included. Here we are dealing with the rate of the reaction, so the constant is rate constant. And the order of the reaction is sum of the powers of concentration of reactant gives to the order of the reaction. Thank you.